It's time for composition of functions.
Peace up, A-Town. Yeah.
So, here's what the notation looks like if we want to take f of g of x, or g of f of x. It looks a little bit intimidating, but I think it's more fun than the function operations. We're taking a function of a function where the output of one function, or like the answer I get from one function from plugging a number in, becomes the input of the next function, written as f of g of x or g of f of x. Another way to see this, f of g of x, could be written as f, and it's a little circle, which means composed with. F of g is the way we say that, of x. It's not a dot, so we don't confuse it with multiplication. Just a little circle. So what this means, let's say we've got two functions. F of x is equal to x squared plus 1, and g of x is equal to x minus 3. And I want to take, we want to find f of g of x. Well, that means I'm like taking the g of x function and plugging it in to the f of x function. So think about it. If g of x is x minus 3, then I'm taking f of my g of x is x minus 3. Well, we've done that before. Let's change colors here. So f of x minus 3, that now means that I'm taking x minus 3, plugging it back into the x function. F of x is x squared plus 1. So f of x minus 3 has got to be x minus 3 squared plus 1. So again, I've taken the value of g of x, which was x minus 3, and plugged it in to the f function. So I'm now taking f of x minus 3. And then simplifying. Remember that x minus 3 squared means x minus 3 times x minus 3. And we're still adding the 1. That'll become x squared minus 6x plus 9 plus 1, which simplifies to x squared minus 6x plus 10. Okay, let's talk a little bit about domain. If I want to determine the domain, in addition to composing my functions, determine the domain. So let's say in this problem, f of x is equal to the square root of 2 minus x, and g of x is equal to x squared plus 2. When I'm considering my domain, I have to think about both functions, but I'm going to compose these first and see what I get. If I want to get f, or take f of g of x, okay, that's going to look like f of, I'm taking the g of x function and replacing that. So I'm taking f of g of x, which is f of x squared plus 2. That tells me to plug in x squared plus 2 anywhere I see an x in the f function. So I'm taking the square root of 2 minus, replacing the x with x squared plus 2, and then I need to simplify this. This becomes the square root of 2 minus x squared minus a positive 2, so minus 2, which, let's see, looks like our 2's go away, so I have the square root of negative x squared. When we're only talking about real numbers, I can't do anything here. I'm going to get a negative under the radical. The only value that would work for this would be when x equals 0, if you think about it, because negative 0 is just 0. So my domain here, it's going to look kind of weird. The domain is just 0 to 0. I'm just including 0. That's it. That's the only number that'll work. Everything else isn't allowed. Let's think about this function another way. So I had f of x equals the square root of 2 minus x, and we had said that g of x is still x squared plus 2. What if we switch this around and take g of f of x? Ooh. So I'm taking g of f of x is 2 minus x. That's what I'm going to be plugging into the g function. So g of f of x, or g of the square root of 2 minus x. So that tells me in the g of x function, I'm replacing the x with the root 2 minus x. And then simplifying. So the square root of 2 minus x squared is just 2 minus x. And I'm adding a 2. So this will become negative x plus 4, or 4 minus x. So that seems okay as far as values of x. However, for the domain, I still have to consider, let's switch colors here, I still have to consider that I can't have a negative number under that radical, since I plugged it in for a value. If that was a negative under the radical, I'd have an imaginary number to plug in. We're only talking about real numbers right now, so I have to think of the values allowed for x in here. Well, if x is 2, let's see, I'm 0 under the radical, so I could take away a negative number, so I've got to be, my x has to be less than or equal to 2 for this to work. So my domain here is actually negative infinity up to 2 and including 2. And lastly, let's look at evaluating these with actual numbers. Evaluating when we compose functions. So let's use new values here. Let's say f of x is x squared minus 7, and g of x is 5 minus x squared. And I am going to ask us to find f of g of 1. Well, I want to work from the inside out, because g of 1, whatever that value is, I'm going to end up plugging into the f of x function. So let's just find g of 1 first. Well, g of 1, I'm plugging 1 into the g of x function, would be 5 minus 1 squared, or 5 minus 1. So g of 1 then is equal to 4. So I've got that value. So if g of 1 is 4, then the next step, I'm asked to find f of g of 1. Well, g of 1 is 4, so now I'm finding f of 4. So I'm taking the output from the inside function and putting into the next function. F of 4 then, now I'm going back to my f of x function, plugging 4 in. 4 squared minus 7. That's 16 minus 7 to get 9. Let's look at one more of these. Instead of f of g of x, or f of g of 1, let's go the other way around and say take g of f of 3. Well, inside first, I want to evaluate f of 3. Well, f of 3, I'm plugging 3 into the f of x function, wherever I see an x. So that's 3 squared minus 7, or 9 minus 7, which is 2. So f of 3 equals 2, but I'm asked to evaluate g of f of 3. Well, g of f of 3, if f of 3 equals 2, I'm really just taking g of 2, which equals 5 minus 2 squared, or 5 minus 4, which is 1. So I could say that g of f of 3 equals 1. Isn't composing functions fun?